So if I said, if I said 4 to the x squared minus 3x equals 4 to the, you could do it, Jeff. 4, sure. I like. What could you immediately do? What must be true in order for that equation to be true?
They're equivalent, so you can bring down the powers.
Yeah, this must be equal to this, and that's the only way that equation can be true. Do you guys see that? So then this would have to equal this. Now, so if I put that left side together, I'm one step closer to an equation like this, correct? What would I get on the left side if I put those powers together? 3 to the 3x plus 1, I love it. 243. In order for this problem to work the way that they want you to make it work, what's got to be true about 243? You have to be able to write it. Yeah. What goes into 243? That's an interesting way to put it. So yeah, it's 3 times 81. 81 is 9 times 9, and each 9 is 3 times 3 times 3. So how many 3's do I end up with?
5.
So I can make that 3 to the 5th, and the other side is 3 to the 3x plus 1, so what must be true about the powers? They must equal each other, and that's an easy equation. Then you solve it, yeah. So that's why the very first kind of equation solving we did with this kind of stuff was like things that can make the bases the same. Because that's the easiest thing. That's what you always hope for. The minute I put like an 11 to the x, I'm like, shit. Can't make it a base of 3, so now I've got to use natural logs or something, right? Okay, yes. Yeah, when I multiply like bases, I add the powers. So what's 2x plus 1 plus x? 3 to the 3x plus 1, yeah. Yep. Because when I add the powers, that's what I get. So if I can rewrite both sides of the problem as the same number to different bases, since they're equal, those bases so different exponents, those exponents have to be equal. That's the only way that could be true. Okay. It's problems like number 12, or not 12. Yeah, 12, sure. No. Like, no, I can't see one like the one I want to say up here. Well, these are all based on E and such, but who cares? Yeah, problem like number 12, I've got to use natural log because I can't make 13 like E to something. Yeah. Whoa. Let's go this way, yes.
Can you go over number 9?
Number 9?
Yeah, on 6.
This guy?
Yes.
Okay. Real quick. What's 7 squared divided by 7? 7, right? So what do I do when I have like bases and I divide?
Use the chart.
Yeah, so what's this side become?
1.
No.
Oh.
How many 36s?
36 to the b.
Yes. I have 3b 36s on top. I have 2b 36s on the bottom. 2b of them cancel, so I have 1b left. 1b 36 left. So again, so let me put this here. We know better about this shit. So, okay. So real quick. Okay. Why? All right. Do you guys agree with me? What's 3 squared times 3 to the 5th? 3 to the 7th, right? Why does that make sense? Why is it not 9 to the 7th? Isn't 3 times 3 9? What are you people doing?
You're adding the exponent.
They have the same base, but we have.
So all powers are is how many of the base I have to still multiply, correct? So this tells me I have 2 3s that I need to multiply. This tells me that I have 5 3s that I have to multiply. Therefore, I have 7 total 3s that I eventually have to multiply. If a student tells me this is 9 to the 7th, I'm like, how do you get 7 9s from 2 3s and 5 3s? How do you make 7 9s from that? There's no way. Do you guys follow? So when I divide, the same thing happens. What is 3 to the 5th divided by 3 squared? Yeah, these don't become 1. I had 5 3s. I divided 2 away. I still have 3 left. Yes. So what is 36 to the 3b over 36 to the 2b? 36 to the 3b minus 2b is 36 to the b. I like it. I like it. So again, that's a beautiful example of math does not give the first shit what is there. When I divide like bases, I put the base to the subtraction of the powers. That's how it always works. If they're letters, if they're numbers, math doesn't care. We care, because we're the humans. We got to do stuff, but the process doesn't change. Okay. So this problem, and then the other side is 216 to the 2 minus b. What do you guys think is the common base between 36 and 216?
6.
Yeah. And if you weren't sure, you could just start to break it up. Or you could do, 36 is obviously 6 squared. So then you can say, what's 216 divided by 6?
72 times 3.
What's 216 divided by 6?
36.
So 216 is 6 to the
Third.
36 is 6 squared. So you can do that exactly like number 6. So that number 9 is exactly like number 6, but they're just dividing instead of multiplying. So you don't add your powers, you subtract them. And then you have these bases that you can rewrite. So real quick, become a thing. There you go. If I have 36 to the b, how do I write that with a base of 6? Well, what is 36? Base 6?
6.
Squared. So what is this? Yes. Okay. So that's something very similar to both sides. So 216, what was it? 216 through the 2 minus b. What is 216? We said that was, and then what do you do with these? Multiply them. Cool. And you know, I have 6 to the stuff equals 6 to the stuff. Stuff has to equal stuff in order for that equation to be true. Does that make sense? So if it's possible to make all the bases the same base, I don't need logs. I don't need that shit. I can just make once I get them there, the powers have to be equal. Right? Is if I'm not able to do that, then I have to bring in logarithms. So if I had like 3 to the x minus 7 equals 11. Now we got problems. 3 to the what power is 11? I don't know. So now I got to use logs. I can't make the bases the same. So now I got to use logs to help me. Okay, maybe. Yes?
So then what would the answer be for the 6 to the third? Would it be 6, 5 minus?
No. What do you do?
Oh,
Multiply. 3 times 2? 3 times b? So this will be on one side and this will be on the other side. So then you get a beautiful little linear equation in b. Right? Because the powers, in order for these to be equal to each other, these have to be equal to each other, correct?
And then you just equal. And
And solve for b. Yeah. Okay. By the way, I don't know if you guys, real quick, I feel a little bit bad about my college not doing a good job of this, but it's undocumented student week, so I wore my little shirt. So there's supposed to be events happening. I got an email about it. I don't know if you got emails about this week, no? Go respond. So all right. Anyway, just so you know, all across the state, this is undocumented student week. So I don't want to know necessarily your stance on some of these issues, but the bottom line is colleges are standing up and trying to help students out who are put into difficult circumstances. So that's it. That's all I got to know. Okay. Anyway, anything else from homework stuff? All right. So remind me, guys, what can you do if you're having trouble with homework? What can you do?
Cry.
Go to the
Cry. Cry is an immediate human reaction. I understand. Sometimes I get homework that's got little drops on it. I'm like, are those tears? I don't know. So as a math teacher, I get to live a life where I make some people cry, which is not the last thing I want to do. It's the absolute last thing I want to do, but it just happens. After you get that out, what do you do?
Your office hours?
Office hours are awesome. If I'm part of the problem, which I admit, I'm open to this. I could be saying stuff that you have no idea what I'm talking about. I just happen to say things in a way you don't pick up. I'm fine. I'm not fine with that, but I understand that could happen. You got tutors. If none of the tutors make any sense, you've got YouTube. You've got basically millions of teachers who put shit up on YouTube. Now, some of it is literally shit, but a lot of it's good. So you can search a topic on YouTube, find a video, and you're like, okay, this makes sense to me, and then go to that person's channel and see what else they have. They might have a complete series on stuff, right? So back in my day, we didn't have the YouTubes on the internet. So I would always get other textbooks to help me get through classes, because sometimes one textbook would say something that I understand, and the other one would say crap I have no idea. And then we would get, I use Shams and REA and different study guides. You guys kind of with me? But nowadays, you got the freaking YouTube. Holy crap. It's insane the amount of stuff is out there. So if you're not looking, searching topics on YouTube and finding people that make sense, I don't understand you. That's so crazy awesome. Yes?
I was thinking about yesterday. So, I
Me
don't know
too.
if you remember, but we did the circle thingy, and then obviously its measurement is 360 degrees, but then you said instead you were measuring it to pi radians.
Totally.
Is that just how, is that just its equivalent? 360 degrees, that's its equivalent?
All right. Are we ready? I'm not seeing many questions, so let's transition. Let's go back to that. Okay. So the very first thing I want all of you to really understand, don't just agree with me, 360 degrees. Everything about that is completely made up. The word degrees all words are made up to some degree, right? But to some degree. The 360 did not have to be 360. Do you guys understand that?
Yeah, it could have been 22.
Could have been 22. Totally. Right? Is everybody sort of with me? I think we went over why we chose 360. So the reason I want you to understand that is there's got to be a better system then, right? We just picked 360. There's got to be something that's based on something physical, not just made up shit. That would be a better thing to use. Okay. So with that in hand, what I talked about yesterday was you can either look at this as having 360 degrees worth of stuff, right? Each degree kind of gives me, if I do 360 of them and get it all the way around. Are you with me? Yes? Okay. But I want you to understand, 1 degree might look like this, right? You guys with me? That's 1 degree of motion. So if I do that 360 times, I get around the circle. There's no reason it had to. Can't you cut this down? Couldn't I cut each of these in half? Couldn't this have been 720? 720 is a nice number too. That could be divided by a lot of stuff. You with me? So we just chose 360. So there's other problems with this that are going to become apparent very quickly. You'll see today when we get there. But this is not a physical measurement. This was an arbitrary choice we made. Now, that doesn't mean it has no use. It's got a shit ton of uses. There's not a damn thing wrong with the choice we made. Nothing wrong with it. It's just kind of arbitrary. All right. Is everybody semi with me on this? Okay, all right. Yes.
No, you're good.
No, go ahead. I'm sorry. Go ahead.
Sorry, I was just wondering, how did they measure pi then? If they had
Okay, so somebody help me out. This is beautiful. I've put you there or something.
It's the ratio between the diameter and the circumference.
There you go.
Yeah.
Yeah,
Oh,
that's
that-
it.
okay.
It wasn't a choice. for pi. Pi was just the number you get. No matter how small your circle is, or the Earth is not perfectly spherical, but if I cut the Earth in half, and I looked at that circle, pretend like it's a circle. It's almost a circle. It's very close to a circle. And I took its diameter, and I took its circumference, and I divided those two. I always get the same number. If you think about that for a minute, that would exceptionally freak me out if I was just realizing this stuff, right? No matter how big or small the circle is, if I take the diameter and divide it into the circumference, I always get the same number. So doesn't it kind of make sense then that we would want to give that number a special symbol? Because that's just
Yes.
weird. Yeah.
Why does it do that?
Say again.
Why is it?
So let's see. Why does that make sense? If I have a circle become larger, didn't every aspect about the circle get larger?
Yes.
Doesn't it go around further?
So the richer.
Circumference got bigger. Didn't the diameter get bigger? They get bigger by the same multiple. Does that make sense? If I have a little circle and it's got a diameter and it's got a circumference, right? I'll call it, oh shit, you can't see anything. I'll call it, why not? We'll call it C1 and D1. With me? If I make a bigger circle, that's 5 times as big.
5C and 5D.
You guys with me? Just like Mike just said, this would be 5 times that. And the circumference would be 5 times this. Yes? So whatever C divided by D here, if I do C divided by D here, see how those cancel? So aren't they the same? Oops, let me put little ones on there. Okay. Does that make sense? So if 2 parts of something grow at the exact same rate, when I divide them, I'm always going to get the same number. So on one level, this is like, well, duh. But on the other level, the really good question is, why the shit is it 3.1415? Blah, 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 right? Because it is. It just is. You guys semi with me? And by the way, I don't want to go too far with this. But y'all, we're not going to suddenly start learning this. But y'all, I keep doing this every now and again. I don't know. If I had done this in this class, why is there a system based on 10? If we had 8 fingers instead of 10, we would count like this. 1, 2, 3, 4, 5, 6, 7, 10. Our number system would be based on, well, let's not take thumbs away because then we don't evolve. A number system is based on 8 then. You kind of with me? We're not going to suddenly do this. I don't want to freak you out. So the number, sorry?
The Simpsons.
Sure.
They have 3 fingers and a thumb.
Oh, I got you. Okay. So we would be in the Simpsons verse. Okay. I thought I was just getting a little something. All right. So I don't know if your question was, why is pi the number it is? But it is the number it is because of all the stuff we chose of how to represent the idea of number. I don't know how else to say that. So it just happens to be the truth that when I do the circumference divided by diameter, it comes out to be the same number. It comes out to be 3.1415.
It's like E, where it represents it.
Yeah, E. I showed you guys 2 places where E comes from. And the weird thing is they seemed very separate, but there's actually a relationship between the two. So, by the way, we see pi come out of probability questions. We see pi come out of the weirdest. You would never expect pi to be a part of an answer to a certain kind of, and it just shows up. And it's because a lot of what we do are based on rotations. It's based on cyclical things. So whenever that's true, pi could show up. All right, that's way too far. Okay. Yes?
So would it be different if it was an oval?
Oh, hell yeah. Totally. Right? An oval is much more difficult to work with. Yes? Because as I move around it, and in fact, of course, our orbit is elliptical, right? You guys kind of with me?
Yeah.
So with a circle, this is relevant because later this semester we'll start talking about what's called conic sections, and that's circles and ellipses and hyperbolas and shit, right? A circle has like one center.
Ellipse has 2.
An ellipse does not have two. It doesn't have any center. It's got two
Okay.
foci. Yes. So in our solar system, when we rotate around the sun is not in the center of our orbit. It's at one focus of our orbit. That's more than we have to worry about right now, but it just happened to come up. Okay. So ellipses are in our future. We don't have to worry about them yet. Do you guys see how everything gets worse with an ellipse because it's not symmetric?
Yeah.
In all directions. It's only symmetric in like two. And as I move, I go further here than I do here. I don't know how else to describe that. Okay. So that's in our future. Don't worry about it. Okay. Now, what's immediately important? So we know that C divided by D equals the thing that we gave the symbol pi. This is where our circumference formula comes from. If I multiply by D, I get this. So I already did this yesterday. And of course, what's the diameter compared to the radius? Yes. So then that's where our formula for circumference comes from, right? Okay, I like it. So, I desperately want this to make nothing but sense. If I am given a circle, a much better way to measure movement around the circle, because that's what an angle does. Doesn't an angle sort of measure? If I start here and I walk here, didn't I kind of go through a certain angle?
Yes.
Okay. And I might as well introduce the symbol for angle right now. The symbol for angle is theta. Okay, I'm not sure why.
Geometry.
Yeah.
Totally.
Like a little geometry section.
Trigonometry is like geometry's big brother.
Oh, so chapter 7 is like trig.
Yeah.
Chapter 7 is trig, yes.
Theta
Cool.
is what?
Sorry?
What is theta?
Theta is the
The angle.
angle.
symbol.
The angles.
Theta is the primary variable that we use for angles.
It looked
Now,
kind of
in an equation, what's the primary letter we use for inputs? X. Do I have to use X? So we will use other symbols. Sometimes they're capital letters. Sometimes they're going to be other Greek letters like beta and alpha, right? I love when you guys make faces. This could have very easily been our letter A. It's just a shape. This is just a shape. This is just a shape. Totally. And that's why in statistics we use this, and I like it because it's related to tails. So it's perfect. Anyway, sorry. It does. Okay. So when I talk about, if I said we have an angle of 45 degrees, this is how I could kind of tell you. The angle is 45 degrees, right? So that letter just represents the most basic way to reference an angle, right? Can we stop for a minute? So you're going to see this letter quite a bit. You will also see any of these, but this is the primary one. So like X versus T, right? You see X much more often, but we see T as inputs too, right? Okay. So coming back to a better way to measure how far I've gone in terms of the angle. Instead of using the made up 360 degrees, right? And again, when I say that, nothing wrong with it. It serves a great purpose, but it's completely made up. It could have been 400, it could have been 22, it could have been whatever. Let's instead use a physical measurement of the circle, right? He's not amused. The radius. So I really want this to make nothing but sense. If I pick this radius up and I bend it and I put it back on the circle, this would be what we call 1 radian. So if I'm standing, there's a crop circle in my field, I'm like, what the hell? And I start to, and the crop circle has a radius of 10 feet. And I walk 10 feet around this thing, scratching my head. I have gone 1 radian of an angle, right? You guys semi with me? You're not with me at all, okay. Okay, so let's do this. Yeah, let me get more well, let's come back to this. A couple more things, and then I'll do some new stuff. Remind me, what is this amount in degrees? 180. Does anyone remember what this amount is in radians? So just to remind you guys, all the way around a circle. Yeah, all the way around a circle is 2 pi radii, right?
Mm-hmm. And then it's
So all the way around the circle is 2 pi radians. So of course this would be pi radians. So pi radians equals 180 degrees. So what's pi divided by 2 radians? How many degrees? 90. Crazy shit, right? And so what's 2 pi radians?
the whole circle.
360.
360. Okay. All right, so let's do something concrete based on what we just did. Because I am talking a lot about if we had 8 fingers and all this kind of shit. You're like, just give me something concrete, Jeff. Okay. So let's do something concrete. What happened? All right. So I know that pi radians is 180 degrees. I know that. That's a fact I know. The same way I know that 12 inches is 1 foot, correct? So therefore, I can convert between the two. So if I had, what do you got, Jeff? I don't know, Jeff. Let's just start nice. What if I had 60 degrees and I want to change that to radians?
You would probably use like a phase conversion.
So what unit do I want to get rid of? I want to go from degrees to radians. So I want to get rid of degrees. So you guys, does this make sense?
Yes.
Put degrees here so they cancel. And I want to go to radians.
Oh, you're doing something different than how we do it in chemistry.
Oh, well, too bad. I'm sorry.
That's fine. I don't like how we do it in chemistry. I know.
Okay,
No,
okay.
yeah, that's perfectly fine. I don't.
Does this make sense? By the way, real quick. If I had 73 inches of wood, right? And I want to convert it to feet. Don't I want to get rid of inches and go to feet?
Yeah.
So then 1 foot is 12 inches, so I would divide these two. And that would tell me how many feet of lumber I've got. Does that make sense?
Okay,
So I'm doing the exact same thing, but here I don't know 12 inches is 1 foot. I know pi radians is 180 degrees. So what do I put next to what's true here?
That
How many radians? Pi radians is
180.
180 degrees. Oops, the degrees is there already, Jeff. So these cancel. So what is 60 divided by 180? Sort of reduce this, right?
That's a third.
3 on the bottom, so I get pi over 3 radians. So 60 degrees is the same thing as 1/3 of a pi radians. Okay, maybe.
How'd you get the 3?
6 divided by 18.
6 divided, that's what I thought.
Yeah. So that would be 1, 3.
It's like a division problem, but you added
So another way to look at this, with really nice numbers like 60, isn't 180 pi? What do I divide 180 by to get 60?
3.
3. So if I divide both sides by 3, I get pi over 3 equals 60, which is what we just did. So when the number's nice, I can sort of not even worry about this. But the reason I show you this is because when the number's not nice, you got to do this shit. Yes?
So the fourth box, is that just like you can fill that in, but like you don't have
Fourth
to?
box. Oh, here.
Yeah,
There's nothing
that needs to go there.
in general for conversion. If I started with like kilometers per second, so I put so many kilometers over 1 second.
Okay,
So this
it could
whole
go
thing
there.
depends on what did you start with. We started with 60 degrees, not per anything.
Okay.
So that's why this is blank. Yeah. Yes.
So are radians like variables? Are they units? Or
They're units, but they're kind of like numbers of radians. So for example, does anyone here happen to know your height pretty well? How tall are you?
I have 2.
5'2". This is going to be strange, but I can measure. Let me do height instead of like. I can measure how tall this room is in Megans. Does that make sense?
Yeah.
If this room was, it's not, but if this room was 10 foot 4 inches tall, it would be 2 Megans tall. Are you with me?
Yeah.
So I'm using Megan as if she's a unit of measurement, which actually makes complete sense. Inches is shit we made up. We're like, it's about it, you know. Megan exists, right? So that's actually kind of a better thing, because I can always go back and see, oh yeah, that's the standard, and then I can kind of make sure you guys are kind of with me.
Yeah.
Okay. Here, what is a part of a circle itself that I can actually kind of use as a Megan?
A radius.
Radius. If I take the radius and go, how many radiuses around, radii, that the number of radiuses, this is radii, right? So the reason we call it a radian is because it's a number of radii. It's how many radii around I go, right? So if the radius was 5 feet and I go 10 feet around the circle, how many radii did I go? 2. So that would be, the angle would be 2 radians, because I went 2 radii around the circle. So it's a physical unit of measurement. Degrees is made up. Yes?
So are these used only for conversions?
No.
No.
You'll see.
Okay.
Right, again, as happens so often in our class, we are at the moment of all the various parts. We have to learn how they all work, and then we're going to see how they all come together.
Okay.
In the near future, I can't really say it yet.
Yeah,
We don't know enough yet. Okay. All right. So let's do another problem. Nice concrete problem. So you guys do this one. 45 degrees. Convert that to radians.
Well, 45 is an eighth of a circle.
Black hole sun, radian. What? Oh, I see. Yeah.
So it'd be 5 over 4.
Sure. You're good. But you got the right. It's a beautiful way to look at it. I love it. And of course, you could do that because the numbers I'm giving so far are nice.
I have a question.
Yes.
Or just do it all first and then
Okay. Yes, ma'am. So, what do I put down here? Yeah, I want degrees down here, so 180 goes here. What goes on the top? I want to end up in radians, so that's pi of those. Yes?
Wait. I was just
Oh, you totally could. Not a damn thing wrong with it. But if you put 90 here, what has to go there? Pi over 2. That'll work. Totally it'll work. Of course it'll work.
So it doesn't matter?
I could have done this one 6 inches, half a foot.
Okay.
As long as this is true. In fact, guys, real quick. I'm almost certain all of you have seen something like this for converting. I don't know. 1 foot, 12 inches. How do they compare to each other? 1 foot versus 12 inches. Equal each other. So what am I multiplying 73 by? 1. That's why this is allowed. So I'm not changing the value, I'm just changing the units. So here, pi radians is 180 degrees. So if I multiply 45 by pi over 180, I'm multiplied by 1. I'm not changing what that represents, I'm changing the unit I'm using. It's sort of like going from dollars to euros or something, right? So it would work. In fact, we'll do that in a minute. You got something else? What's up? Okay, so then the degrees cancels. 45 over 180, can you reduce that for me? Yeah. You'll get there eventually if you do a few steps, but yeah, so you get pi over 4.
So you can't use decimals, right?
You could. You could. It depends on the problem. Like, if this problem was a word problem and said, how far away do you have to go? And your answer was pi over 4 miles. I'm like, what? So then you would, you'd multiply it out. Just like any word problem. You're not going to tell me, so how far away is that? Square root of 11 miles. Who the hell are you? So if it's a word problem, then you're obviously going to make this a decimal, so it makes more sense, but yeah. Which, what I just said sort of illustrates the earlier point. Radians are a physical measurement, correct? So I could end up with a miles or something if I use radians in a certain way. I could never do that with degrees. Degrees are totally made up. So later we'll see radians is almost always the way you want to go because they are actual physical measurements. They aren't made up. Okay. I have nothing against degrees. I just wish they'd never been
Do you
invented.
mean degrees like angles, or degrees like angles and like temperature are made up?
Oh, no. So, yeah, it's unfortunate we use the same word.
I know, right?
Yeah.
Like, what-
So right now we're talking about angles.
Okay.
Yeah. Yeah, the degrees for temperature is a whole other thing. Okay. Yes. Oh, okay. Go ahead.
I think I got confused because when I did 45 divided by 90, I got 45.
Okay, here we go. Ready? So we'll do what Isabel suggested. She said, all right, Jeff, that's nice and all that kind of shit, but I want to do 90 degrees is pi over 2. Is everybody cool with the fact that 90 degrees is pi over 2?
Yeah.
So that is a valid thing. Now, does everybody agree with me, though, that that's much cleaner than that?
Yeah.
But again, it's not a... So you ready? So here you get that, right? You with me? Is that cool? 45 goes into 90 twice, yes? What happened? Is that all right? What happened? No? No guessing. 45 goes into 90 how many times? Twice. Correct? You'll get 0.5, yeah. And then you get, what do you get here? You get pi over 2 over 2. Does somebody remember how to do this?
Oh yeah, you
Pi is being divided by 2 and then being divided by 2 again, so it's being divided by 4 overall. We got the same answer. Of course we got the same answer. Yeah, yes.
I got 0.25 because I divided 45 by 180.
Totally, sure. So you get 0.25 pi. It's normally, we don't like mixing decimals with pi because if I'm writing pi, I'm already saying I'm not going to use decimals. Does that make sense? Because pi is a decimal itself. But technically, there's not a damn thing wrong with this. Is that cool?
Yeah. Would you put the R? Would you put 25 pi R or just pi?
Yeah, oh, yeah. I'm sorry. I really got to be more careful. This should have radians on it. Now, to be honest, I don't have to do that. If I see this, that's degrees. If they tell me an angle has a measurement of 7, that's radians. If it's got no units on it, we assume it to be radians. So if I say I have an angle with a pi over 4, that's pi over 4, you know I mean radians. If I mean degrees, I have to say degrees.
Would you need us to put radians on the test or quiz?
No.
So if a question is asking you, like, make this degree radians, you could use either pi radian or pi over 2 radians. Like,
Yes, but again, which one of these was easier? I would say this was.
Okay.
But if this is easier, then there's nothing wrong with that. There really isn't. You can use, it's exactly like I said up here. Watch this. All right, let me make this clean again. Real quick, if I do 73 inches to feet. So I got rid of inches and went to feet. So 1 foot is 12 inches. What is 73 divided by 12? What's that, 6.083?
0.08.
Okay. It's my one skill. All right. Now watch this. If I did 73 inches and I want to kill inches and make it feet, but I go, okay, well, I know half a foot is 6 inches. What's half of 73? Divided by 6.
Same answer, yeah.
Yeah, of course. The math don't give a shit. In fact, by the way,
It's kind of an extra step, right?
by the way, isn't this 1/12? Isn't this also 1/12? Divided by 2 divided by 6 is?
Yes.
So again, as long as what you're putting here is a true conversion, it'll work. So what do we normally use? The cleanest one, the one that didn't have fractions inside of fractions. What can you use? Anything that's true, right? Yes.
Okay, so I have like 2 questions. So the first one, so like radians ever cancel? Can you like cancel the word radians or? Is it
Totally.
Okay.
In fact, real quick. All right. I'm sorry, Meg. 5'2", right?
Yeah.
Okay, so let me make that, so that's 62 inches. Everybody with me? So 1 Megan is 62 inches. You with me?
Yeah.
So what if something was 7 megans tall? We'll just say megs.
Oh, you do 60 times 7.
You do 6.2 times 7, right? Now, when you do 6.2 times 7, doesn't megan just sort of like go away? Because each megan is 62 inches tall, right?
I was just about to say, what?
Right?
Yeah.
This isn't like megan inches. This is just inches, correct? So radians do kind of get out of the way when you're converting them back into degrees or whatever. Okay, maybe.
So are the 2 pi radians, are they like the circumference or?
Totally. They're not, no, careful. All right, I gotta be careful. Any given circle, 2 pi r is the circumference. Do you guys agree with me that this, another way to say this is this, the distance around this is 2 pi radii. If the radius was 5, wouldn't this be 2 pi 5s? Okay. And what did we decide to call the number of radii? We decided to call them radians. So that means, let me be careful, circumference is 2 pi r, the angle is 2 pi radians.
Got it.
So if, again, let me say this again, if I take the radius of a circle, physically pick that sucker up, it's in my hand, see it? And then I'm like, I become little tiny Superman and go, right? And then I put it back on the circle. There it is, yes? That is an angle, correct? Now, real quick, this is the distance I've walked on the circle, but it also goes through a certain angle. So all the idea of radians does is it kind of puts those ideas together. There's a connection between those. So if I go 1 radius around any circle, I have gone through 1 radian of an angle. If I go a little bit more, doesn't the angle get the same amount bigger? So if I go 1.3 radians around a circle, radii around the circle, I've gone through an angle of 1.3 radians. Okay, maybe. So now I don't have to rely on, what number you guys want to use? How about 360? That's shit. What about 400? What about 22? Shut up, right? You guys I like that 20 guy in the back. 22 guy. Okay, maybe.
There's a range.
Understood. Oh, cool. There you go. He took the radius and curved it, and you can put it. So someday I'm actually going to make something I can put up here. Anyway, all right. Now.
Is there a symbol or number for like 3/4 of the way?
Okay.
Like you do a quarter of the circle.
So if you went 3/4 radians, is that what you're saying? Or if you went 3/4 of the way around?
Yeah.
Oh, if you went, okay. All right. How is this? What's the whole way around? 2 pi radians. So if I went 3/4 of the way around, that would be 3/4 of 2 pi,
Okay.
which will be
1.5.
3 pi over 2.
Okay.
Now, real quick, watch this. Okay, this is actually not bad. All right, we can't spend forever on this, but I want you to get the physical idea of this down. Can you guys, if I go 3/4 of the way around, don't say anything. Can you draw a circle and then indicate where you would end up? And we're always, pretty much when we move around a circle, we're always going counterclockwise. Because we're weird. It was chosen for us back in time, so that's just the way we do things. So this would be how far?
75%.
That'd be half of the way.
Halfway.
I'm sorry, that'd be a quarter of the way,
Yeah.
which is pi over 2.
Wait, we're doing it out of 4.
Totally. So I want to go 3/4 of the way, right?
Okay, got it.
This would be half of the way, which is pi. So this will be
3/4.
3/4. And again, remind me. So this will be 3/4 of the way around, correct? You with me? All right. And what is 3/4 of 2 pi?
5.5.
3 pi over
3 pi over 2. I love it.
2.
You with me? Is everybody with me?
Yeah. Wait, isn't there like a
find the coordinates of each of them?
We're getting there.
Yes, there is.
We're getting there. And this is why it's always interesting to teach a class where I have some people that know a little bit about this and some that don't know anything. I'm like, hold on to that. We're getting there. Okay. You're fine. You're fine. Yes.
Did you take the clusters in your measurement?
Say again. Sorry.
Are those like the 4 major measurements, like the 2?
Yeah, these are obviously the, like, 4 of the most important spots. So this would be 0 degrees, 0 radians, correct? This would be 90 degrees. How many radians? Pi over 2. Because this is 180 degrees, also known as pi radians. Now we know what this one is. Now, that's 90 plus 90 is 180 plus 90 is? 90 plus 90 is 180 plus 90, 270. But now we know what it is in radians. 3 pi over 2. Now, real quick, why does that make sense? Remind me. So if I look at 3 pi over 2. Now, here's what's nifty. Nifty? Sure, Jeff. If I'm going from radians to degrees, it is much easier. Because every pi is how many degrees?
180.
180. That's a fact. You guys can remember this, right?
Yes.
Pi radians is 180. Because the whole way around is 2 pi, so of course halfway around is pi, and that's 180 degrees.
Mm-hmm.
Bam! What did we just say? Pi is what?
180.
So when I convert from radians to degrees and there's a pi sitting there, that kicks so much ass. Because every pi is 180. So I just got to put a 180 there.
Okay.
What's 180 divided by 2?
90.
90. And what's 90 times 3? 270. Of course it is, because that's what it's supposed to be, right? Okay. Nothing magic there, but I mean... Okay, I like it. So let's do a couple of more disgusting ones. We've done some nice ones so far. So what if I want to convert 1 radians? Anybody curious? I'm sure you guys are. I keep going back to pick the damn radius up and curve it, do a little Superman joke and put it down. Right? I keep doing the radius and you curve it. And somebody out there must be like, how many freaking degrees is that shit, Jeff? How many? What would your guess be for that? Just based on the way I've drawn this. It's not perfect, but what would your guess be? 60, 70. Okay, so let's see. Does anybody want to know exactly what it is?
Yeah.
Yeah.
I don't care. Oh, yes, I do. Okay. So how do I go from radians to degrees? Do I have a pi in this? Do you see a pi here? Shit. So I got to do it this way. What do I want to kill? I want to go from radians to degrees. What do I put down here?
Pi equals 1.
What do I put here? What unit? Rads, because I want them to die. See? So up here are degrees. So what's the conversion I know? How many what's in what here?
Pi rad.
Pi rad, 180. So isn't this 180 degrees over pi? Okay, can somebody please divide that? Do you guys know where your pi button is?
Yeah.
So if you have a graphing calculator, should be on the right side, I believe, right?
You have to press second.
57.2957795.
Blah, blah, blah. Okay. So whoever said 60, that was really damn close.
Yeah. I think that was like all of us.
Yes, I think you all said around 60 something. You guys semi with me? Again, so real quick. If I take any circle in the universe and I take its radius and I curve it and put it right back on itself, I've gone through 57.29 degrees. But we can also call that 1 radian. It only makes sense. That is 1 radius worth of distance. So using radians is a much more physical, real thing than degrees. Degrees, totally made up. You with me? Okay. Okay. Now, I've got a little outline for myself. Okay. Any lingering questions so far? Are we doing all right? Okay. So there's an idea. Well, let's see. Let's see if you guys are cool with this. Help me out, everybody. So if I go, well, this is 180, correct? Okay. So that's if I go half a turn. Either direction, I end up at 180, correct?
Yes.
if I go a full turn, how many degrees have I gone through? 360, right? 2 pi radians, 360 degrees. So right now I just asked for degrees. So what we're going to do going forward is when we hit a new idea, we're going to start with degrees and then bring radians in, because degrees we all kind of have a feel. If I said, can you draw a 45-degree angle? I feel pretty confident all of you could do that. Will it be perfect? No, it'll be pretty damn close. You all could do that shit. If I said draw a pi/6 radian angle, can anybody do that? Not yet. Some of you guys maybe, if you went far enough and need tricks, a little. Okay. You guys, and it's just because we don't understand. So when we do some new shit that involves angles, we'll first do the stuff with degrees and then we'll use radians. Now, an immediate good question would be, well, if we can always use degrees, then why are we using radians? Because we can't always use degrees. So we'll get there. Okay. So real quick, if I go more, so if I start here, 0, right? And I go, that's 180. That's 360. If I go, now it's 361. Now it's 362, right? So if I go, how far have I gone now?
270.
So this is 360.
540.
540. Good.
Oh,
So in a sense, isn't 540 degrees the same thing as 180 degrees? So if somebody wanted me,
Yeah, they're equivalent.
if somebody wanted me to face that way, and they told me, all right, Jeff, I need you to turn all the way around. Okay. Okay, now I need you to turn halfway. Okay, good. And I would have looked at them and said, why the shit did you just tell me to go halfway in the first place? Are you guys kind of with me? So any degree, any angle that is more than 360 is more than one revolution. Does that make sense?
Yes.
Okay.
So do you divide it by 360? Like when
You don't divide by 360. Well, you could sort of, but you subtract 360 until you get back.
Yeah.
So, for example, if I had an angle of, what do you got, Jeff? You could do it 800 degrees. Isn't that more than one revolution, right? In fact, you guys see that that's more than two. What would two full revolutions be?
720.
720. So can you tell me, if I spun through 800 degrees worth, where would I end up facing?
360.
No.
80 degrees.
So if I subtract, let's see, let's do this.
180.
No. If I subtract 360, guys, wait. If I take one revolution out, that's 440, correct? If I take another revolution out, that is 80. So there you go. So if I spun 800 degrees, so that would be one spin is 360. So when I do this one, it tells me how much further I've got to go. Another spin would be another 360. So now I've got to go 80 more. So I end up at 80 degrees, right? Let me put it here. Does that make sense? Let me see if this name makes, oh, what's up? If I go 370, if I turn 370 degrees, how much past the full revolution have I gone? 10 degrees, right? One revolution is 360.
Oh.
So if I turn 370 degrees,
Oh, yeah,
I'm going to end up at 10 degrees, yes? So if I had 370, I could just subtract 360 and see, oh, I'm actually facing 10. So if I just subtract all the extra revolutions, I can see where I actually end up facing, right? So you could subtract 360 until you get a nice number between 0 and 360. That's kind of like the standard way to do it, yes?
So you knew to stop at 80 degrees because you can't subtract.
Well, I could, and it gets negative, which is just being going this way, right? But
Would
that-
make sense with it.
It does, totally. So let's go there. I'm sorry, go ahead. We'll go there in a minute. So, if I wanted somebody to turn, so here's 0, right? You guys with me? So I'm facing this way. That's 0 degrees. Yes? Facing 0. And if I want somebody to turn 20 degrees, I would go here. That's 20. Couldn't I then say, what would negative 20 degrees mean?
Just the other way.
just go clockwise instead. So negative angles also work. So watch this. Okay. So I'll bring the name in a minute. If I told somebody to go negative, you could do it, Jeff, negative 220 degrees. Don't say anything. Can you tell me between 0 and 360, where would they be facing? Don't say anything. So they go back 220 degrees. Where will they end up facing? See how you guys do this. And to give you an idea,
You want us to draw or?
I want you to think about it or do something. If you're not sure what to do, you could always draw a duck. Make me think like you're doing something. But I prefer you do something. So right now, you might not have a clue how to do this. And you're sitting there, I don't care. I don't care if you know how. I haven't told you how to do this yet. I just want to see what you guys try. Let me know if you think you have the answer.
140 question?
Oh, okay.
Yeah.
No way. I just-
So real quick. What just happened a second ago? Somebody said, how do I know to stop? Because if I subtract 360, what do I get?
Negative.
Negative 280,
Yeah.
right?
Yeah.
So couldn't I add 360 back on? I went, oh shit, I went too far. Let me add 360 back on. So you can look at a negative angle as if somebody subtracted 360 too much. So then how do you get back to normal? You just add 360.
Yeah. But you could add another and get, so how do you know when to stop? Because before it's easy to know when to stop because you get the negatives, right?
Because it's between.
When the answer is
0
between 0 and 360, right?
Okay.
Anything above 360 has a full revolution. Take that shit out. If I want somebody to end up facing here, why would I tell them spin around 7 times?
Right.
Right? You guys kind of with me. Unless, I got pinata and I'm going to do that whole thing. No? Nobody? I'm sorry if you never had a pinata. Maybe? So it's taking out extra revolutions. And I always look at a negative angle as if, oh shit, somebody took too many out. Somebody just adds some back on. So if I had negative 1,020 degrees. So now you can start being smarter about it. That is a lot extra revolution somebody subtracted, right? So what's 2 full revolutions? 720. So let's add 720 to this. What do you get?
Still negative.
Negative 300, right? So if I add one more, I'll get back into 0 to 360 territory, right? So where do I end up? 60. So if I told somebody to spin clockwise 1,020 degrees, they will end up facing 60 degrees. Okay, maybe.
So when it's still negative, that's when you know that it's still.
Yeah, generally, so there's nothing wrong with negative angles, but if I want the answer to be like a standard angle, like within one turn, I want it from 0 to 360 then. I would have to keep going if I still have a negative, yeah. There's not a damn thing wrong with saying negative 10 degrees. That just means go this way. There's nothing wrong with that. But negative 10 degrees is also known as 350. Is that cool? Okay, maybe? So these are what's called, so does this make sense? If I turn negative 10 degrees, I end up here, right?
Yes.
If I instead turn 350, don't I end up
Same place.
same place?
Yeah.
So watch this name. This is not a bad name. Math people, we get okay sometimes. I would call 350, kid, come here.
Oh, just 350.
I would call 350 and negative 10 degrees, I would call those co-terminal.
I remember that.
Let go of your past, right?
No,
So
I'm good with this.
one way I can say, if I stop spinning, couldn't I just say I have terminated spinning?
Yeah.
Right, especially if you're a Doctor Who fan, exterminate. So if I stop doing something, I've terminated that. So if I turn 10 degrees, negative 10 degrees and stop, that's where I've terminated. If I turn 350, I have terminated at the same place. So they are co-terminal. The name actually is not horrible. It's not the best, but it's nowhere near the worst. Okay. So what's coterminal with negative 1,020 degrees? 60. Those are coterminal because they end up with somebody facing the same way. Does that make sense? So how do I find coterminal angles? That involves adding or subtracting a certain number of 360s, right? Take some revolutions out. Yes?
So, I was just gonna ask, never mind, sorry.
You're good.
I
I'm
was
sorry.
gonna ask what are we gonna use this for, but I realized you were just
Everything.
gonna say the same thing you said before.
Everything. Yes.
Okay, so 350 and negative 10 are coterminal because when you're standing, like if you were to
If I'm
stand,
facing 0,
you're standing on the same angle.
yes, I end up facing the same way. So I always think about angles as I always see myself in the center. So if I go 45 degrees, where do I end up facing? Right?
Yeah.
So I'm looking that way. If I go negative 315, that will also end up facing same thing.
Okay.
So those are
Just one's a longer
coterminal.
path.
Yeah, exactly. Yeah.
So does coterminal mean they're like equivalent to each other?
Yeah, they end. I like the word terminate in there because they end in the same place. So if I do what both of the things want me to do, I end up facing the exact same way. Right?
Just finding the angle.
Just finding the same direction of looking, yes. So again, I always think of an angle as I'm standing in the center. Jeff, that doesn't work. I'm standing here. There's Jeff. And so 45 degrees is me looking this way. Right? So I turn and now I'm looking this way. Negative 315, I still end up looking the same way. I just get there in a different way, right? Okay, maybe. So, I mean, if I want to go to my friend's house, I could go this way, or I could go that way. Aren't those coterminal paths?
Yeah.
They both terminate in the same place, right? Okay, maybe.
Like the alternate routes when your GPS reroutes.
Totally. Which I always find funny when it's like, do you want to go this way? It's 10 minutes slower.
I know.
No. All right, sorry.
I know.
You are on the worst route. Oh, thanks. Thanks, GPS.
It sometimes messes me up and I'll accidentally go on like the gray route instead, and then I'm like, it's okay, it's an alternate route, and then it adds like 6 minutes.
Totally.
Woo!
Totally. All right. Okay. So let's do this. Okay. So we got some basics down. We got a brand new unit called the radian. We learned how to convert between what we know degrees and the new thing radians. We got coterminal angles that are going to come into play. At the moment, they're just relatively simple math problems. Just find the number that would be coterminal with this thing, right? Then here's another idea. Okay. So help me out. If I have a circle and it's got a radius of 3, right? You with me? And I walk along here, I go 3 feet along here. So the radius is 3. We put it down here.
3 what?
Oh, sorry, 3 feet. Okay. What's the angle in radians?
1.
1 radian. Is everybody cool with that? So the angle, if I put theta there, the angle would be 1 radian. You with me? Yes?
So whenever there's like a section off, like section like that, it doesn't really matter what the values are. It's always going to be 1 radian.
Yeah, if I walk along the circle exactly how long the radius is, I've gone 1 radian.
Okay.
So it's funny, again, just to remind you guys, if I had a bigger circle, the radius is bigger, and when I walk, I end up
Yeah.
same place. That's why it's a standard unit for an angle. Okay. Now, man, I am not utilizing space well. Let's say I have a different circle. And I go, and the radius is 5 meters. And I walk something that is, and I walk through something that is 2 radians. How far have I walked? 10 meters. You guys kick so much ass. So you ready? So those have been easy. Yeah. So what if I have a circle? and the radius is something, 3 inches. And I walk what's equivalent to 1.4 radians. Right? I shouldn't put it up there, sorry. 1.4 radians. Can anyone tell me how far I've walked?
4.2.
Yeah, what'd you do? Again, what did you guys do every time? Yeah. You guys sort of with me?
Multiply the
So if I
radius.
1.4 radians means 1.4 radii along the circle. And how big is each radii? How big is each radius? 3. So I have 1.4 of these. So I've gone 4.2 what's? Inches. Good. See, that's what I meant earlier. Radians just gets out of the way. Yes?
So you don't have to convert even then?
Here's why. Here is the exact. Okay, this is perfect. So in general, if I have a circle and I know the radius and I want to know the length that I'm going along, I'm given an angle. Here's exactly what you guys just did. You took the radius times the angle, didn't you? That's exactly what you guys did. The name of this is arc length. Arc length.
That makes sense.
And of course, since there's no s anywhere in there, we're going to give this the variable s. That was a joke. There's a reason it's given the letter s. Very often, some things we use are because of, like, for example, why is slope m? You guys ever wonder about that?
I do know this.
It's based on a French word. French word, so slope is a way to walk. French word for walk is marcher. M. Okay. So
Yeah, that was my brain.
this is a whole different thing. So if I want to know the arc length around a circle and I know the angle I go through, I just have to do this. Now listen, if this was degrees, I could not do this. Why were we able to do it? So again, if I know the radius is 2 meters, and I go through an angle of 1.1 radians, bless you. So I want this to make physical sense. 1.1 radians means 1.1 radii, radiuses. So 1.1 of these. So of course I multiply, correct? Isn't that exactly what the formula says to do?
Yes.
So that would be 2.2. Are you with me? Bless you. If the angle was in degrees, all of this goes to shit. So if I went through 62 degrees and the radius was 10 meters, I would not just multiply those, because physically, how does that make sense? Is degrees number of radii? No.
So that's when you do the conversion.
This is not a physical measurement. So if I have an equation, people at home, if I have an equation where, this is going to sound really weird, where the angle is out on its own, do you see how this angle is out, free? It's not inside of a function. Are you with me? You'll see what I mean when we get to the trig functions. It must be, there's no choice. It must be in radians. Because I'm trying to get a length, so of course I need the angle to be a real physical idea, not this made up degree bullshit, right? Yes.
So when you say that, do you mean that it's always going to be put in radians, or it always like needs
If
to
it
be?
isn't, so how would I do this problem? That's my next question. How would I do this
So it
problem?
just always needs to be put
I'd
in
have to convert this to,
Okay.
how do I do that? I do convert it to radians.
One rad.
180.
180 is 1 radian.
Yeah, no? How many radians?
Pi.
Pi radians, 180 degrees, right? So this is one conversion where neither one of them is 1, because if I made either one of these 1, the other number would be gross. So we just use pi and 180.
So does that mean the pi stays in?
Not in this case. Because what do I want? Isn't this, like I said earlier, isn't this going to be a length?
Yeah.
Do I want to tell somebody, well, how far away is it to your house? 20 pi feet. Who are you? right? No, I'm sorry. I don't. So this is an actual word problem. I want to get a real physical answer. So can somebody just S equals r theta. So the arc length is the radius times all this shit. You can just throw all this shit in here. Put all that crap in your calculator, right?
So how do we just leave the pi? Isn't it like a number?
It's a number, and you got a pi button.
Oh, so you want us to?
Yes.
So could we leave the pi if it wasn't a word problem and it didn't really matter?
Yes.
Okay.
And we did that earlier. When we converted 45 degrees. We made it pi over 4 radians, and we stopped.
Okay.
Because all I wanted was the angle. So pi over 4 is much better than whatever that would be.
Yeah.
Yeah, it'd be 0.7, blah, blah, blah.
This would end up being a decimal, right?
Totally.
Leave it in the decimal, or
Yes.
would you want to do it in fractions?
No. Sorry, what's...
Decimale.
You should end up with, let me see if I can estimate this. Sure I can. Yeah, you should end up with like 11 or 12 or something.
Oh, so it's a whole? Nice.
10.82.
10.82? What's?
0.821.
Radian.
Radians.
No.
Ooh, degrees.
Degrees.
No.
What are the degrees?
Meters. Meters.
But we just converted it to radians.
What's radian mean? Yeah, the angle is in radians, right? This is meters, yes?
Yeah.
Oh.
Radians,
Yeah.
now,
So you got rid of the.
10 meters is how big every radius is, and this is the number of radii. All right. All right. Going forward, I'm going to need to, I think, just to let you know, I'm going to need to cut down our question and answer session, because otherwise we're going to get like really behind. So
The one in the beginning.
I'm still going to have a question and answer session. I'm just not going to be able to let it go as long as I have, because I don't want to stifle anyone's questions, but more of you've got to use my office hours, more of you got to use tutoring, more of you've just got to do more stuff. We desperately need to continue moving forward. So just to let you know, if I cut stuff short, you can still see me after class or whatever. Okay.